What's going on, everybody? In this video, I want to talk about how we find the zeros of a function. So when I say zeros, all I mean is what x values are going to make the value of the function 0. When I plug in this x, am I going to get a 0 out? That's all we're trying to ask whenever we ask for the zeros. So I'm going to work through a few examples of different types of functions and how we would execute them. For this first example, let's say that I had the function f of x is equal to 5x squared plus 4x minus 1. So my question is, what x values can I plug in to make the f of x 0? So this is a quadratic equation, and we know we can solve quadratic equations through a bunch of different ways. You can try factoring, extracting square roots, completing the square, or the quadratic formula. I tend to use the quadratic formula whenever the coefficient in front of the x squared term is not 1, just because it's kind of a direct way to get the answers for x. So if I use the quadratic formula here to solve for x, well, first of all, this is how you set it up. So we want the value of the function to be equal to 0. So you set it up this way. I have my function, 5x squared plus 4x minus 1, and then set it equal to 0. And so I'm going to find the zeros by using the quadratic formula. So if x is equal to negative 4 plus or minus 4 squared minus 4 times 5 times negative 1 all over 2 times 5. So this is going to give me negative 4 plus or minus 4 squared is 16. So 16 minus a negative 20 gives me square root of 36. And 2 times 5 just gives me 10. So this is negative 4 plus or minus 6 over 10. And if I reduce and break apart, I see that my x values are going to be negative 2 over 5 plus 3 over 5 and negative 2 over 5 minus 3 over 5. So when it comes down to it, the values of x that are going to make this function equal to 0 are negative 2 over 5 plus 3 over 5, which gives me 1 over 5. And the other one is going to be x is equal to negative 1. So if I plug in these two x values, I'm going to get a 0 back for f of x. So in the second example that I have f of x is equal to 8x plus 3 divided by 11 minus x. So again, since I'm looking for the values of x that are going to make this function 0, the way that I set this up is I have my function, which is 8x plus 3 divided by 11 minus x, and I just set it equal to 0. If I want to find the values of x that make this equal to 0, I just set the function equal to 0 and then solve for x. So if I take this denominator and I multiply both the top of this fraction and the other side of the equation by the denominator, this is what ended up happening. So I have 8x plus 3, 11 minus x, times 11 minus x is equal to 0 times 11 minus x. So check out what happens. So the 11 minus x on the left-hand side cancels with each other. And then on the right-hand side, I have a 0 times 11 minus x, which is just going to give me 0 again. So what I'm left with is just 8x plus 3 is equal to 0. So this is a useful fact because when you're trying to find zeros of rational functions like this, all you have to do is set the top number, the top part of the fraction, equal to 0 and then solve for x. So I subtract 3 from both sides and I have 8x is equal to negative 3 and then just divide by 8. So my 0 is going to be x is equal to negative 3 over 8. If I plug this value in, I'm going to get 0 for f of x. So in another example here, I have f of x is equal to the square root of 2x plus 1. So again, to set this up, to find the zeros, I take my function, square root of 2x plus 1, and just set it equal to 0. So what I can do is I can square both sides of this, and the square root of 2x plus 1 squared just gives me 2x plus 1, so I've eliminated the radical, and 0 squared, of course, is just 0. So again, we have a nice scenario in square root functions, if you want it to equal 0, just take the inside of the root and set it equal to 0. So I subtract 1 from both sides, and I have 2x is equal to negative 1. And then when I divide by 2, I see that my 0 is x is equal to negative 1/2. If I plug in 1/2 here, or negative 1/2 here, I'm going to get 0 out for f of x. And for my last example on this topic, I'm going to do f of x is equal to x cubed minus x squared. And I want to find the zeros. What values of x can I plug in here to make f of x equal 0? So my setup is the same. I take my function, which is x cubed minus x squared, and then I set it equal to 0 and just solve for x. So what I notice about the two terms on the left here is I have an x squared in each of them. So I'm able to factor that x squared out. And when I do that, I'm left with x squared times x minus 1 is equal to 0. So I have two terms that I can set equal to 0. The first one is I have x squared is equal to 0, and then x minus 1 is equal to 0. And if I solve for both of these, I see that x is equal to 0. And that one's easy to check. If you plug in 0 for x, well, both the terms cancel and you're just left with 0 for f of x, so it works. And then I have x is equal to 1 as well. 1 cubed is 1, 1 squared is 1, 1 minus 1 is 0. So these are both of the zeros of this function. So I hope this was a clear kind of intro to finding zeros of functions. This is something that I'm going to touch on a little bit deeper whenever I go into different types of functions, because the remainder of the videos of my algebra playlist are just going to be deeper dives into the types of functions. But in this little playlist, I'm trying to get just an introduction to what functions are and some of the things that you can do with them. But one of the most important things that we do in the study of functions is finding zeros of functions. So I wanted to use this video to explain what a zero was and how we would go about finding them in a more general sense. So I hope this video was helpful, and stay tuned for the next one. Take care, everybody.